Hi everyone, and welcome to my channel of electronics and control videos. In this channel, we always discuss the real-time implementation of electronic systems. Particularly, the focus remains on the implementation of analog and digital controllers. Since these controllers are to be implemented using some kind of tools. For example, Proteus, NI, Multisim, LT Spice, and similar kind of tools. So we must learn these tools at first end. Proteus is a kind of tools which can not only be used to develop and implement analog controllers, and we can test them in real time. This has one feature which not every other programs does have. That is that it can be used to uh, program and test and real-time test microcontrollers. Uh, Many popular kind of microcontrollers can be programmed within the Proteus environment, uh, and the real hardware can also be programmed using Proteus itself. So that's why we are going to mutually learn and understand how Proteus can be used to do various things. In this tutorial at hand, we are going to learn some basic techniques which will help us understand the environment of the Proteus. First one is the schematic entry. Then, I mean how the circuit can be developed within Proteus. I hope that many people already know that how the schematic can be entered in the Proteus. But I think there are some tips which many people will not be knowing. Next, we will uh, simulate this circuit using analog simulations, and then we will plot these simulations for uh, some kind of research things. So let's begin. The schematic that we will be using this tutorial is shown here. This is a simple circuit having three resistors and one inductor and a sinusoidal source. So this circuit is just selected arbitrarily to understand certain concepts. So let's get into the Proteus environment and begin a new project. First thing that we must name this project. Let's name this project as tutorial project. Tutorial project 001. Next, then the next option is that we are to create a schematic from the selected template. Later on, we will be talking about these templates. For now, we are going to just select the default one. Then we are going to only understand how schematic works and how it can be simulated. So we will not be creating PCB. We have to leave that one. Also, we are not going to work on firmware. In later videos, we will be discussing that how PCB can be developed using Proteus and how firmware can be developed in Proteus videos. So this series of tutorials is going to be really fun for everyone, learners or professional people. We have set up everything. Uh, we are to do on we are to work on the schematic only. So I have left layout and firmware. Layout is concerned with PCB design, and firmware is related with the microcontroller programming and testing and real-time testing. So these two options we will be discussing later on. Let's finish. Okay, now we are in the schematic environment. This area is the working space where we can develop our circuit. This the area over the window. This is the toolbar. This area is the menu bar, and the this line over the menu bar is called the title bar. I think everyone knows, whoever used Windows system. Also, this area is, we should say that this is the instrument area, maybe. This contains various things which are used in the while we are working on circuits in Proteus. This small window is called overview window, and this area is called the component selector. I think is called, yes, it is called component selector. So let's begin. Okay, so we have seen that we are to work on this schematic. It will require resistors, capacitor, inductor, and a sinusoidal source. The first thing that we need to do is to collect these components from Proteus libraries. So to go to Proteus library, we are to click on this P button, or yes, this is the only way we can go to the library. Or I think we can right click in the schematic and then we can go into the place, and then we can go to component, and then there is only one option, that is the libraries. So if we click on the libraries, we are into the pick device window, and here we can search and collect various component. Okay, so let's go other way. If we click on this button, we are directly into the window. So these are the two ways that we can get into the Proteus library. Okay. Okay, we can search all the components, or we can first scroll the category of the component where our component could be. Then we can select subcategory and then the manufacturer if we are going to select some manufacturer. But for the sake of this tutorial, we just be having normal components. So we are to find for resistors. Yeah, resistors. Here it is. And not specific resistor is required. Only generic resistor is required. So we are to select that one. For that purpose, I think we should type here RES and resistor. Okay. This is the one we are looking for. This is another option, but we are going to select this one. Okay. So just double click here. We can click on OK, uh, but we can double click and we can find other resistors as well. So as I double click on this component, a see in the component window, we can see that the resistor is now available. Next, we are to find an inductor. Here it goes, inductors. Again, we are to just select generic inductor. So I have selected this one. I will double click on this component, and here it is in our component. Next, we are to select capacitor. Here it is, capacitor, and likewise we are to just select a generic capacitor like this one. We can also click OK, but if we click OK, I mean we are out of the component window. So we will again get back to component window. So I think instead of clicking on OK, we should double click on the window and all the components will be available here. Then we can pick them and can develop our circuit. Okay, next we need a sinusoidal source. So I will type sine here, and here it is. Click OK, and now we are here. Okay, now we are to develop the circuit here. Again, I want to show the schematic we are going to work on. Okay, the schematic consists of three resistors and one capacitor and one inductor, and also one sinusoidal source, and also the two resistors R1 and R3. They are oriented horizontally. This resistor is oriented vertically, and the capacitor and inductor and the sinusoidal source, they are oriented vertically. Why I am saying that why I'm telling there why how they are uh, connected in the layout, because it's important while we are developing the schematic. So let's get back to the tutorial, the window. Here we can see in the overview window, we will be looking at orientation of the component. We can see that all the components are indicating their orientation. So, except the sinusoidal source, all the components are oriented uh, horizontally. So we are to orient them before we put place. Although if when the components are in the working window, they can be oriented, they can be rotated. But before this, I mean, this will be easier to orient them before they are placed here. Okay, so let's begin with the source. It is already uh, vertically oriented, so we do not need to do anything. So as I come out of the component window and into the working area, we can see that with our mouse a pen is connected. This is actually indicating that this component in the overview window is connected with this pen. So as I left click in this window, this it is placed here. So if I again left click and other sinusoidal source will be, I mean, yet the sinusoidal source is selected here, it can be placed again, but we are to now place the resistors. So let's do that. Okay, so this is the resistor. It is already horizontally oriented, so we just left click here. It is here. Next, we are to select the next capacitor. Here it is the capacitor, and it is horizontally oriented. If we click on this button, this can be uh, this can be oriented vertically. Just place it here. Now again we need another resistor, so we will click on the resistor and note that it is vertically oriented, because here we can see that it is required to be like this. Okay, so here come the resistor. Again we need the resistor. We have to click on this component, and it is vertically oriented, but we must have it horizontally. So we will click on this button to have 0 degree orientation. Note that the grid in the grid here in the Proteus environment is helping us to place the components in the schematic. Next, we need to place the inductor. There it is, and it is oriented. Let's rotate it. Okay, and it was okay. The placement of the components is complete. We should go to this is selection mode. We should go to selection mode, and then as we uh, as we come closer to the terminal of any component, note that a square box appear at the terminal. uh, it is Let me show you here. A square box appear. It indicates that this terminal is ready to be connected. When we left click on this, a wire will be attached with it, and then the wire can next be connected to the terminal of the next component. Note that we can rotate our whole window using the overview window. I mean, if I left click in the overview window is attached with my mouse, and then I can uh, rotate, move the whole window while keeping my mouse within the overview window. And then we are to again left click to come out of the overview window. Okay, here it is. Left click and note that although I can directly connect here, but it would be much better to have a connection in the corner and then connect to the next component. Okay, our circuit is almost complete. One final thing is that we must have a ground within our circuit. So we will go to terminals mode, and this is the terminal mode, and we would select ground connection from here. Okay, and let's connect the ground here. This is just a component like all other, so it can also be connected within the circuit. Okay, next step is that we are to edit these components if we need to do so. So as it is only a tutorial circuit, it's not a particular circuit, so I will not edit all the components, but I will edit the sinusoidal source because we really don't know that what frequency or what voltage it will be providing us. So how to edit the properties of any component? Firstly, we should go to selection mode. Remember, firstly we should go to the selection mode. So I am selected mode now with my mouse. Simply a pointer is connected. So okay, now if I'm to edit the properties of any component within the schematic, first if I hover my house is converted from simple pointer mode to hand mode. Okay, which means that this component is ready to be edited. So I will have to lift left click on the component, and then I can right click, and I can select the added properties selection here. Okay, so the properties added component window will be in front of me, and this the contents of this window will change according to the nature of the component we are editing. Okay, I'm going to close it, and I will going to tell you another way of doing that. I mean another way of accessing the edit component window. Again, I will hover my mouse over the here, and I will left click, and then if I go to Control plus E, I will again in this window. Okay, there is another way to do so to access this window, and that way is that we can go to the any component just clicking the E button, the E key on our keyboard. But we must know the name of that component uh, to, for using this key. So if we click E key on our uh, keyboard, it pops up find an added component dialog box. We are to add the component name here. We want to add it. We can see on our schematic that we want to add it v1, so we will just enter v1. Okay, and we are into the added component. So let's edit it. These are the properties of this component. uh, Although you can edit these properties, that is the part reference, part value, you can name, or I think you should not change this part reference, but you can change all of the everything else. So the DC offset is default. All things are default, and we don't know what are the values of these defaults. So that's why I'm recommending that we should change them. So before we could change it, let me tell you something. Let's have another, and the sinusoidal source is defined as V is equal to V. Let's say, let's call it V naught plus Vm sine of 2 pi f e minus, or just say plus theta. So in theory, this is a generic sinusoidal source definition. This number is called offset. This number Vm is called the amplitude. This number f is called the frequency of the sinusoidal source, and this theta is called the phase or phase shift of for this sinusoidal source. I mean, if we draw this source, normally the sine wave looks like this. Okay, I mean, if it is having an amplitude of 5 volt in the positive direction, and it will also be having 5 volt in positive direction if this v naught is 0. But if v naught is positive, thus this sine wave will be shifted that volts upward if it is positive, and if it is negative, it will be shifted downward. I mean, your original sine wave is actually moving up or down with the presence of offset. So we can say it in general vertical shift. I mean, if you want to give vertical shift to your wave or your signal, you can have non-zero offset to the definition of your source. And this is the amplitude. I mean, if offset moves the sine wave upward or downward, the reference value, which in general this is the zero line, this also moves up and it also moves down inside. So this is the definition of the your sinusoidal source. So keeping these things in mind, let's get back to Proteus. And I'm not going to have offset, so I will make it 0. Then I want have an amplitude of 10 volt. I would put 10. Then I want to have a frequency of, let's say, 100 hertz. No time delay. This time delay will actually be the phase in the sine wave. So this has to be selected according to the frequency. I mean, if the frequency is selected to be 100 hertz, which means that one cycle will complete in 10 milliseconds. So you are to have a time delay within this value. I mean, 10 millisecond, and, and the complete cycle completes in 360 degrees. And if you want to have a phase shift of, let's say, 90 degrees, or let's say 45 degrees, so 45 degree is actually 1 over 8 of the total cycle. So that means that the time delay would be 10 millisecond divided by 8. So that becomes, I think, 1.25 milliseconds. So you have to select your time delay according to these calculations. But we are not going to select this, so I will do it 0. Similarly, there is no damping factor in the component, so I will make it 0 as well. Okay. For that what is the damping factor, you can, I think, google it. uh, Damping factor is actually tells that if there is exponential component within the source. Okay, so now we are ready with everything. We have values for the components and we have set everything to be simulated. So let's continue working on this schematic on this circuit. We are to now simulate this circuit. For the simulation, there are two ways to simulate this circuit, but we are to decide that what we want to see regarding this circuit. I mean, this is an electrical circuit. It can have current and voltages. The current will be flowing through the branches, and the voltages will be happening across nodes, happening on nodes. So we are to decide that what really we want to have. So this is the inductor coming. I mean, do we need to know the voltage across the inductor, or we want to know the voltage across the capacitor, or we want to know the current flowing through this branch or through the C1 R2 branch or the R1 branch? I mean, what do we need to know? So, whatever we want to know, we are to place component. I mean, we are sorry, we are to place related probes to measure that quantity. So we will go to the probe mode. This is the probe mode, and we have here current probe and the voltage probe and current probe. So let's begin with the voltage probe, and here in the overview window I can see the probe is shown. So we will just connect the voltage probe here. This probe is named as R321. Definitely we can edit it. So I have selected it by left clicking on this node, and then I will right click and this edit this label. Let's call it inductor voltage. Okay, click OK. So this is now inductor voltage. Okay, now if we just click on run, circuit is simulating, and the voltage across the component inductor is 0.0003159558. Okay, so this is how the circuit is simulated. But usually for these kind of circuits, we want to see the waveforms of the circuit. So for that purpose, we always place oscilloscope within the circuit. So let's go to uh, let us go to here virtual instrument mode, and here you can see there are various kind of components that we can select from. Today we are going to use oscilloscope, and in later videos we will also be working on other instruments. So let's select this one, left click here. Oh sorry, we will have to stop the simulation first. Okay, here it is. Let's use the first channel of the and then now the oscilloscope is connected. We are to just click on play, and here it is. What the problem is here? Uh, we have selected channel A because voltage is very small. So we are to just adjust the gold pavilion so that we could see the waveform. Um, we can also adjust the time scale here. So this is the voltage waveform. If we do not want to see the output from other channels, so we can switch them off as well. These are the slider button. We can do that. Okay. So we are using channel A. So channel A is on AC mode, uh, AC mode, and then that this is DC mode, ground mode, and off mode. So if we do not want to have the output from some channel, we can move this slider to off. So channel C is has disappeared. Now channel B is blue. This blue line will disappear if we go to off, and similarly channel D is green, it will also go off. You see. So this is how the waveform can be seen in the digital oscilloscope. Okay, let's stop it and let's do another thing. For that, we need to delete this one, and let's also delete this connector. Okay, now we want to have a plot in our schematic. So for that, let's zoom out the circuit a little bit, and we need to a graph window into our schematic. The circuit is of analog nature, so we can place an analog window here. We can from we will have to select the analog graph from here. So with the selection of analog graph, you can see that uh, we are having uh, pink color box to be drawn here. Yeah. So this is a graph where we will be able to plot the voltage across the inductor. What we need to do is that we are to connect this probe with this graph. So for that we will right click on it and we will edit the graph. No, sorry, we are to add trace option. We are to go to add trace option. So here there are four options by default given. We will just select the inductor voltage here. Okay, and the inductor voltage is now attributed to is now attached to probe P1 in the add Darwin trace window. So this is appearing here. Okay, so we will just click OK, and we have note that inductor voltage is appearing here, which means that this node is not connected with the graph window, which means that if we click on run button, uh, this voltage will be plotted in this window. Okay, so let's do it. uh, but it has not done that. I think we should go here. Start time is 0, stop time is 1. As the one cycle will complete in 10 milliseconds, so we should select the end time to be 50 millisecond. 50 millisecond. Let's click OK. Oh, sorry. We need to click on. We need to click simulate graph. Here it is. Here we can see the voltage across the inductor because this is quite small value, and so the voltage is in microvolts range. Okay, so this is how the analog simulation can be done within the Proteus. Thank you so much. Keep watching more videos of this nature.